In today's activity, we kind of explored the effects of different values in a function. So we explored what a number being multiplied by the function does, what happens when you take the function of a number times x, when you add something inside the parenthesis, when you add something outside the parenthesis. And so in this first example, we're kind of talking about all the stuff that we have talked about in the first half of the chapter with regards to this one parent function, the absolute value of x. And on your, I suppose you can call it kind of a reference sheet of parent functions, the absolute value of x kind of looks like this. All right, so what is its domain? Its domain is all real numbers. So it goes from negative infinity to positive infinity. Its range starts at 0, goes to infinity. Its intercepts, the x and y intercept is 0, 0. It is symmetrical over the y-axis. It is continuous. Its end behavior is that as x approaches negative infinity, f of x approaches positive infinity, and as x approaches positive infinity, f of x is still approaching positive infinity. The intervals on which the graph is increasing or decreasing, it is increasing from 0 to infinity, and it is decreasing from negative infinity to 0. Here we're going to use what the parent function x cubed looks like to graph the quantity x plus 2 cubed plus 4. So this is just a translation. Well, let's first think about what x cubed looks like. So x cubed goes through 0, 0, 1, 1, negative 1, negative 1, and it kind of does this. Okay, so if I'm taking these 3 points and translating them so that I'm graphing that function, then I'll be going to the left 2 and up 4. So basically, you can take each of those red dots and move them left 2 spaces, up 4, connect those dots, and you're pretty good. Okay, so starting with this point, 1, 1, I'm going to move it to the left 2 spaces and go up 4. So 1, 2, 3, 4. 0, 0, left 2, up 4, and then negative 1, negative 1. To the left 2, up 4 is here. So if I kind of just copy what the basic shape of it is. That's pretty much all I'm looking for. In this example, we're kind of doing the exact opposite. This time we have the graph, we're trying to come up with an equation for it. So before we can come up with an equation for it, we need to see how the parent function and the graphed function are related. So let's consider the parent function 1 over x. That kind of looks like this. And that's a really crude drawing. This is 1, 1, and this is negative 1, negative 1. So notice that it's been kind of flipped upside down, which means since it's reflected over the x-axis, it's taking this 1 over x and putting a negative sign in front of it. And then on top of that, it's kind of moved down. All right, so let's consider negative, the quantity, 1 over x would look like this. Passing through 1 comma negative 1 and negative 1 comma 1. But it's not passing through those points. It's passing through points 2 spaces below that. 2 spaces below. Below is a vertical distinction, which means I'm adding or subtracting something outside of the parenthesis. And since it's a vertical shift, it's outside, and it is what it says it is, it's minus 2. So there it is. There's our g of x equation. Pause your video to work through the Your Turn Below, Part B. Here, we're also describing the transformations and graphing them. So the parent function, f of x, in part A, is the absolute value of x. And the negative 3 out in front means that it is vertically stretched. By a factor of 3. The fact that that a value is negative means that it's reflected over the x-axis. And that minus 2 inside the absolute value means there's a horizontal shift. And remember that horizontal shift is kind of sneaky. It's doing the exact opposite of what you would think it's doing. So you see a minus 2, it's actually going to the right. Shift, if I could spell, of 2 spaces. Okay, so the parent function looks like this. The g of x graph is going to have that vertex point shifting to the right 2 spaces. So I'm going to plot that first. I know it's going to be going upside down, and I know that it's a vertical stretch of 3. So if you think in terms of the absolute value kind of having a slope of 1, the parent function has a slope of 1, then the g of x graph is going to have a slope of negative 3. So down 3 over 1. Down 3 over 1, and there it is. That's my g of x. Part B, my parent function, is the square root of x. And because I have a negative inside the grouping symbol with the x, this is being reflected over the y-axis. And I've got to be really careful about horizontal shift when I'm reflecting over the y-axis. What you need to realize is that this g of x is equivalent to the square root of negative, and I've got to factor that negative out of the expression inside that radicand. So it actually becomes the negative of x minus 2, which means when you first looked at it, you might have thought this graph is moving to the left 2 spaces. It is not. It is moving to the right 2 spaces. Okay, so let's consider what the parent function f of x looks like. It starts at 0, 0, passes through 1, 1, passes through 4, 2, and it kind of does that. Okay, this graph is being reflected over the y-axis, and it's moving to the right 2 spaces. So this point, 0, 0, is moving to the right 2 spaces, and it's being reflected over the y-axis, so it's opening in this direction. This is my g of x, this is my f of x. Finally, in this lesson, we're looking at graphing a piecewise defined function. And rather than struggle through how to use a parent function for each individual section, since a graphing calculator is permitted on the EOC, let's go ahead and use Desmos to show us what's happening with this graph on the interval that we're interested in that graph, and then we're only plotting that portion of it that's appropriate to the piecewise function. Here's what I mean by that. My first piecewise function has x minus 5. So I go to Desmos. X minus 5 is this line. Okay, well, what portion of this line am I interested in? The part that's less than or equal to 0. So at 0, it's at negative 5, and then it has a slope of positive 1. Okay, so coming back to my graph, it goes through negative 5, 1, 2, 3, 4, 5, has a slope of positive 1. So the first part of my graph looks like this. Second part of my graph is x cubed. Well, we already know what x cubed looks like. It passes through 0, 0, but it's not going to here. It's going to have an open circle there, just so that I know kind of the boundary of it. It goes through 1, 1, and it goes through 2, 8. And that is a closed circle because of this, or equal to. So it does this. And then the last part of it is 2 over x. I might need a little bit of help with that, so let's go back to Desmos. Let's graph 2 over x. And I'm interested in it from 2 onward. So I'm going to have an open circle at 2, 1, and then maybe another point that I could graph just for reference is 4, 1/2. So on my graph, I've got an open circle, I said at 2, 1, and then, oh, my bad, 2, 1. And then 4, 1/2, so 1, 2, 3, 4, right about there. So it's kind of doing that. And there's our piecewise function. Part B. X plus 6 quantity squared is the first part of the piecewise function that we're graphing. And we're only graphing it for values less than -5. So I look at Desmos, I graph x plus 6 quantity squared. And at -5, it's -5 comma 1, and then it comes down to -6, 0. So -5 comma 1, 1. It was -6 comma 0, and then this was our vertex here at -6 comma 0, so it's kind of going back up. Oh, but it's an open circle here because it's not or equal to. The second part of it is that it equals 7 between -5 and 2. So here's -5, comma 7, and it's flatlining from there to here. Those are both closed circles because they are equal to. And then the last part is absolute value of 4 minus x. So let's take a look at what Desmos says that looks like. Absolute value of, no, absolute value, there we go, of 4 minus x. And I'm only interested in the part of that graph that is greater than 2. So at 2, it's 2 comma 2, then 4, 0, and then it's going back up. So open circle at 2 comma 2, and then at 4, there's my vertex, it's coming back up. And that's it.